And now I'd like to present to you the chi-square test of independence. We're going to review the formula for it, and we're actually going to calculate one using Excel. So we've been talking about candidate preference surveys. Sometimes when people are doing polls, they ask for other information besides the candidate preference. They might ask for example, their age group or their gender, ethnicity, political affiliation. And all of these variables can be combined to see if one variable depends on another. So this table right over here contains candidate choice data and the age group data for the sample, and both variables are categorical, right? They're both categories, an age category and a candidate category. But we can find out if the ratings of the candidate are related to age. We can ask the research question two different ways. We can say, does the age group breakdown depend on which candidate is supported? But that doesn't really make a whole lot of sense. The better way to ask is, does the candidate preference depend on the age group? Like, will there be different candidate preferences depending on the age group? So this is the chi-square test for independence. The null hypothesis would be, in this case, the candidate support pattern does not depend on the age group. The two variables are independent. The alternative hypothesis is that the candidate support pattern does depend on the age group. The two variables are not independent. There's a relationship between the two variables. Now this is really interesting because you look for relationships prior with correlation, but those were with equal interval and ratio data. This is looking for relationships between two sets of nominal data. So what we need to do first in our chi-square, I'm going to sort of demonstrate it with some slides, and then we're going to do this in Excel. The very first thing you need to do is set up the array of the ages and the candidates and the number of people that are in each of these groups. Now, I could have the ages at the top and the candidates off to the side, does not matter. But what we do need to do is add totals here. That's going to help us in our calculations of our chi-square. And then not only the totals for the rows, but also the percentages for the rows. So for example, we have 80 people altogether that were in ages 18 to 29, and 80 is 20% of the total. So we need to have our array set up like this. So, and I've already said this, so there you go. Our next step is to fill in our expected frequencies, and this is easier than it looks, but it's the most time-consuming thing of the whole chi-square formula here for independence. Basically, what we're going to be doing is taking the percentages of the total groups for the rows and multiplying those percentages by the total in the column. So for example, ages 18 through 29 represent 20% of the distribution. So that means that when we're looking at just candidate A, 20% of the total votes for candidate A should be here in 18 to 29. So we take 20% times 200 to get 40. We take 32.5% times 200 to get 65, and we fill in these expected frequencies in this way. The overall age group breakdown is just the percentage of age groups in the sample, and it's the same regardless of the candidate. The same percentages here are going to apply to this candidate as well. So the frequency expected is the total N for A times the age group 1 percentage. We just did that. And that equals the expected age group 1 supporting A. That might be a lot of words. All right. And we've already talked about that. Okay, so our step in calculating the chi-square is to set up a table that looks something like this, and I have this for you in the Excel sheet. We're going to find the expected frequency, like I just talked to you about, and then we're just going to do everything like we would normally do a chi-square. The degrees of freedom, though, are going to be interesting because we're going to take the number of rows minus 1, we're going to take the number of columns minus 1, and then we're going to multiply those two together to get our degrees of freedom. Okay, let's do our test of independence. Go ahead and pull up your Excel sheet. Okay, I'm on the third tab, and hopefully you are too. And what do we have here? We have the candidate data for candidate A and for candidate B split out by the different age groups. I've also added in all the things that we're going to need to do a chi-square. Plus, I've also added a total columns here and a total row and total column. We need to do all that. So let's do that first. Let's find our totals. I'm going to do equals, and I'm going to sum up the observed frequencies here. It comes up to 200. And I'll do the same for candidate B. I'll sum up the observed frequencies. Okay, so we have 200 in each group. All right. The next thing I need to do is add up the rows. So I'm going to take 50 plus 30. And through Excel magic, I can just drag down and it will do the subtractions or the additions, sorry, for all of those. Great. Now I like to check my work, so I'm going to make sure that I have 200, not 200, but 400, because that'll be the total of everybody. Yes. 200 plus 200 equals 400. This equals 400. We're all good. The next thing I need to do is make my percentages for each of these rows. So for 18 to 29, there were 80 total out of 400. So what percent is that? That's going to be 80 divided by 400. All right, I'm going to drag it down. So I always want 400 to be in the denominator. So I'm going to just put a $sign here and here. Make my life easy. Then I can just drag them down. Whoop. Oh, it's not cooperating. I'll blame the computer, not me. All right, so I want to add these up to make sure they add up to 1, because these are proportions that should add up to 1. I didn't do something. What did I do wrong? I only summed up the last one. That's not good. That won't do it. Now it should be at 1. Good. All right. Next thing we're going to do is find our expected frequencies. And like I explained previously, this just involves taking the percentage in the row and multiplying it by the total in the column. So I'm going to do that. I'm going to go equals. I'm going to hit the percentage 20 times 200. So let's just talk about what that was again. So I know that 18 to 29-year-olds represent 20% of the population here. So in that case, that means that 18 to 29-year-olds should have 20% of 200. That only makes sense. All right, I'm going to do the same here again. This time I'm going to take 33% times 200. Why did that come up negative? I guess I put a negative sign there. You're getting to see all my errors. That's okay. The next one is 35 times 200. And this one is 13% times 200. Very good. All right. And this should add up to 200 too. So let's just see if it does. Make sure. And it does. So we're in good shape. For the next one, I'm going to, in the interest of time, I'm going to do a quick shortcut here. So I'm going to take the same percentage here, 20 times 200, but this time I'm going to tell Excel to keep 200 in the second part of the subtraction all the time, and then I can just drag it down. Good. And I'll do my double check on my math just in case. And all is well. All right, so now that was the hardest part, is finding that expected frequency. Everything else is easy. I'll just do it fast. I'm going to take the score minus, or the observed frequency minus the expected frequency. And I'm going to drag that down for everybody. And then I'm going to square this deviation. And I'm going to drag it down. One more. All right. And now I'm going to take this squared deviation and divide it by the expected frequency. And if I just drag it down, it'll do the same for every row. I'll be golden. All right. Now, let's do the same for the next one. Observed frequency minus expected frequency. And then I'm going to drag down, and then I'm going to square those scores. All right. And then I'm going to take each of those scores and divide it by the expected frequency. I'm kind of in the zone right now. I'm kind of zen and feeling it. There we go. All right. So our chi-square asks us to do something. It asks us to then sum up all of these and add them together. So let's do that. My sum of this is 5.31. And my sum of this is going to be the same, right? 5.31. So my chi-square statistic is this plus this. And I can end up with a chi-square in this case of 10.63. So let's think about the significance level of 10.63. First of all, let's think about our degrees of freedom. We have 4 categories here and 2 categories here. So 4 minus 1 is 3, and 2 minus 1 is 1, so our degrees of freedom are 3. So if we look at our distribution table, we're going to look for 3 degrees of freedom at 0.05. I've already kind of filled that in for you. That value is 7.81, and our calculated chi-square was 10.63. We are going to reject the null hypothesis. We're going to say that candidate choice does depend on age. And here's just a summary of what we just did. We calculated the chi-square, and we found that it is significant. We reject the null hypothesis, and we conclude that the candidate supported does depend on age group. The 2 variables are related. All right, that's the chi-square test for independence. Hope you enjoyed it every bit as much as I did. And if you have questions, I am here for you this week.